Okay, year 8 revision. Here we go. So area equals to pi r squared, and circumference equals to 2 pi r. Circumference is the outside. Okay. Perimeter is the area is the inside here. If you wanted to find a sector of the circle, so imagine you just wanted that part there. Okay. You will be given an angle, which is labeled as theta for now, and the way you would work out your area is equal to, so for sectors, so shapes like this pretty much, it's equal to pi r squared still, but you go times it by theta over 360. So whatever this angle is, divided by 360. And the only reason why that is because it will be a fraction of the whole 360-degree revolution. Cool. So if you've got a semicircle, right? That angle is obviously 180. What's 180 divided by 360? A half. So you get your timesing your area by a half, which is half a circle. So it does make sense, this thing. But that's it. And then for your circumference, same thing. 2 pi r times by theta over 360. Okay. Then did you learn tangents and whatnot as well? So let's use a different color just quickly. So a tangent touches the curve just at one point. So tangent, 1 point of contact. That's a secant, the line. Okay, and that's called, the actual area is called the minor segment, and that's called obviously the major segment. Okay, so secant is the line. Secant, and I'll put the line. Cool, so you know this is the minor segment. So segment is actual thing. Okay, that's pretty much with circles. I mean, there is nothing else to it. I might as well do the volume of a circle since we're here. So volume of a, well, it's not called a circle, of course. It's called a cylinder. But because it's a circle, and then it's got depth, it's going to be pi r squared, and that's going to be multiplied by height h. So your volume equals to pi r squared h. Cool?
So it's just times.
Yeah, just times.
Yeah.
It's easy, isn't it? Volume. I've always told you volume is just a 2D object multiplied by depth. So if I have a rectangular prism, imagine that was a rectangle, for example, it would just be length times breadth times width, which you already know. But it's actually just this area, so length times breadth, and then you just times it by its depth, for example. And that's it. So if I had a Toblerone, well, it's just the area of my triangle times by its depth.
Okay.
That's the volume. Okay, so area of triangle times depth equals volume. Okay, oops. I think that's about it I can think of from circles. I don't think it's that bad. It's more the fact that these formulas. Okay? So you've got diameters. Obviously a diameter is double the size of your radius. So just halve it to get your radius. Right? That's about it. Okay, equations now.
You've got like single, and then you've got double, and then you've got triple,
I know.
and so on and so on and so on.
Equations. So we've got x plus 2 equals to 5. What do I want to make the subject?
X.
Okay, how am I going to do it?
I just normally knew because you already know it's 3.
Yeah, okay, and then so how did I do that?
Oh, you take away.
That's it, see?
Take away.
Once you
Oh,
know
okay,
that,
5.
what's it? Okay, x plus 2 equals to 5. So what you do to one side, you do to the other side. The trick is leave the x until the end. That's it. Alone. Okay. So if I've got 2x minus 5 is equal to 10, what am I going to get rid of first? The 2 or the 5?
Yeah.
The 5, because leave the x until the end.
So you do.
So how do I get rid of a negative 5?
Minus plus 5. Minus. No, wait. Oh, wait.
You plus 5
yeah,
to get rid of it.
Plus 5 and then you plus it on 10. And that becomes 15.
How do I get rid of the 2 here? How is
Divide
it being attached to the x? It's times.
So you
divide 2.
And then you divide 15, and then that equals 15 over 2.
That's it.
Woo.
So another one. 3x minus 6 is equal to minus 10. Alright, what do I get rid of first? The minus 10, the minus 6, or the 3?
minus 10. Minus
No,
I get rid of the minus 6 because I want to make x's the subject. Okay?
And so that becomes plus 6, and then plus 6 onto 10, that equals 3x.
Minus 10 plus 6 is minus 4,
Yeah,
and then you divide by 3.
and it's still negative.
It's still negative. You haven't changed the sign. Good job. What if I put it as a fraction now? So 3x over 5
Just remember you've got 20 minutes left.
plus 2 is equal to 8. Alright, what do I get rid of first? The 3, the 5, the 2, or the 8?
5. 2.
Whatever's attached to the x, leave it to the end. You can't keep forgetting that. You gotta keep saying it in your head. Yeah, go. So I get rid of the?
2. Take away 2.
I'll let you have this one.
Now what do I get rid of? The 3 or the 5?
5.
How?
Times.
Because it's being divided by 5? How do I get rid of the 3 now?
Divide.
Because it's being multiplied by 3. So you just do the opposites each time. Cool. 5. Alright, what do I get rid of first? Minus 6, the 5, or the negative 2?
You get rid of the division part. No way.
Negative 6.
Yep, how?
Plus 6.
Oh,
It's attached to the
because it's
x.
negative, sorry, my bad.
Plus 6.
Plus 6.
I always think that it's like, it's, it's minus.
No, that's a negative number.
I know.
Equals to minus 12 plus 6. Minus 12 plus 6 is minus 6. Times it by 5. Times by 5. The 5's cancel out, that's the whole point. Minus 6 times by 5 is minus 30.
Oh, yeah.
And then how do I get rid of a negative 2? That's being multiplied by x. I divide it by negative 2.
Wait. Oh, wait, now I realize. Don't worry, I realize.
Minus 6 times 5 is minus 30. How do I get rid of a negative 2 here? I divide it by negative 2. You don't just divide it by 2. You divide by negative. So the negative divided by negative is positive. And that's why you got x there. Okay, number 6. What about if there's x's on both sides? Okay, well, your aim is
X on the one side. Okay.
alright, so you gotta get rid of the x's and the numbers on the other side as well. So how am I gonna get rid of this x?
But wouldn't that make it 1x?
Wait, that's 3x.
Yeah.
And I want to get rid of this x. So how am I going to get rid of this x? I will take away x. X's are gone, and I will take away x from this one. So that becomes 3x take away x is? How many x's? 3 x's take away x.
Isn't it just 2x?
Yes. Plus 2 is equal to 5. I want to get rid and then look, that's back to normal. How do I get rid of the 2?
Take away 2.
Yeah, 2. And yeah.
Alright, now what? I want x's on the one side. So what? Tell me.
Take
You
away
get x from the other x, and then that becomes 2x.
2x take away x is
just X.
just x.
Wait, 2x. Wait, why do we? Oh yeah, don't worry.
2 chocolates take away chocolate.
Bunch of them.
Exactly. Don't look at me like that. I've done this for too long. X
I mean,
plus 5 equals to minus 7. How do I get rid of the plus 5?
take away 5.
Taylor, wasn't it easier looking at chocolate ways? Honestly, it was, wasn't it?
Yeah.
So do that then. If you find it's hard with x's, and I know you do, so try to think of them as anything. 2 pens, take away a pen. That's what I was trying to say. One what? But one, yeah, you have to say something, right? Otherwise, if you just say one, you mean what would you assume? One what? $1? One anything?
One window.
Yeah, one window.
One window.
Okay, so you got to say that's it. That's what the 1 pen is. So 1 and then pen.
Okay.
That's it. So here we go. Let's go with 5x take away 2 is equal to 3 take away 2x. Okay, how do I get rid of this negative 2x?
Take away 5X. 5X.
No, positive plus.
You plus 2x.
Positive plus whatever.
And then you, yeah, doesn't matter, plus 2x. 5x plus 2x is?
7X.
7x.
Do you know why? Yeah? You get that?
Yeah.
Take away 2 is equal to 3. How do I get rid of this 2?
Plus 2.
Then
How do I get rid of the
divide by
7? Divide by 7. Alright, let's go number 9. Are we okay?
Yeah.
With this better now? Alright, oops. Let's do all the negatives so then you are not afraid of them anymore, hopefully. Alright, how do I get rid of this negative 4x?
Plus 4x.
And then, alright, enough. You, let her talk. Plus 4x, negative 3, plus 4, you got 1 left now. If you just put in your calculator, you get that. X minus 2 is equal to minus 5. How do I get rid of this negative 2 now?
You plus.
Done. Alright, that's it.
Okay, wait.
Yep. That's something you put in your calculator, that part there.
Yeah, but how come it's negative 12 or 5?
It's not it's plus 2.
Oh, okay. That makes sense.
Sorry, plus 2. Cool. Alright, what's the next one? Pythagoras.
Woo!
I love Pythagoras.
Yeah, exactly, easy one. Alright.
C equals A plus B.
C squared
Plus C
equals to
squared.
A squared
Yeah.
plus
Yeah,
B
that's squared.
squared.
Oh, I remember. I used to have problems with this because I kept memorizing it.
Alright now, C squared equals A squared plus B squared. So if I gave you a triangle and I told you that's 4 and that's 3, let's find this hypotenuse here.
4 squared plus 3 squared.
We'll label it as x, for instance. So x squared, because that's the hypotenuse, opposite the right angle. Right, that's the
Wait, what did? Oh, yeah. C
hypotenuse.
stands for that,
These ones
and
doesn't matter,
then
as long as they're
side.
sides. So x squared equals to 4 squared plus,
plus 3
what's 4 squared? 16. 16 plus 9 is 25.
What? Oh, yeah.
Your
because you have to
calculator,
times-
no, plus, that's plus. Calculator, 4 squared plus 3 squared. Your calculator will do it for you. I'll give you that 16 plus 9. 3 times 3 is 9, right?
Yeah,
4
because
times-
you. But if you didn't have a calculator, you'd times
4 times 4, not 4 times 2,
4 times 4.
and because it's squared.
Oh, because it's okay, and there's.
Squares mean,
Because you double it. Yeah, you double
Like
the
that.
number.
Yeah.
Okay.
that equals to 25.
I got confused. I always used to get confused with that. I always used to do 4 times 2. I didn't double it.
Oh, yeah, definitely. Your calculator, don't worry. Let's see. X equals 2, and then how do I get rid of the square here? You root it.
Yeah,
Square root of 25 is 5.
square root.
Alright, let's try to find this one again. x squared equals to?
Equals to 5 squared plus 12 squared.
5 squared is? What's 5 times 5?
10, we're 25 years, sorry.
Then plus 144.
X equals to 13 when you square root it.
Yeah, and then you, yeah.
I'll put it here, square root, and then
Okay,
square root.
cool.
Cool? And x becomes 13. But what if I didn't want to find the hypotenuse? What if I wanted to find the shorter side?
Oh, I hate this.
It's a squared equals x squared take away b squared.
Yeah, pretty much. A
Or just
squared,
swap it over.
c squared minus b squared. That's pretty much what happens. So if I gave you this as 20, and I gave you this as 15, I want to find this now.
20 squared.
So 20 squared take away
15 squared.
equals x squared. Right? Equals to x squared. That's what we just wrote here, right?
Yeah.
Or, Taylor, the way I was showing it to you so you can understand it, was x squared
Yeah.
plus 15 squared. Right? As we wrote here, x squared, the side squared, plus the next side squared equals hypotenuse. So equals to hypotenuse. C squared, isn't that C now?
Yeah,
Isn't that A, for example, and B?
yeah,
So there is A squared plus B squared equals C squared.
yeah.
Or
I used to the other way, that way.
20 squared equals to x squared plus 15 squared. They're both the same thing.
Yeah.
Okay, and then you can see you got to take away 15 squared here to make x a subject, and that's where you get this. Alright, so what's 20 squared? That's 400. What's 15 squared? 225. That gives you 175.
How do you do that off the top of your head?
This is a genius.
And then x would equal to roughly 13.2, all three. If you want to know the exact answer, which I should give to you guys, it's going to be 13.2. Okay, so I was right. Now, we move on.
Sure, or you just saying that? Oh, okay. I thought you were just saying that because you're way off again.
Alright,
Yeah, 10 minutes.
don't count.
No, I don't know how we're going to kill the rest of these topics.
Okay. We can do it. Probability is easy, I hope. Right?
Yeah.
You failed?
I don't even know if I failed.
I got a low score when I did.
Yeah, no wonder why you're failing, because you're bloody making further macho man on a bottle.
Probability.
Easy.
It shouldn't be hard. So if you failed, then we've got to work on that one, especially at your age, because it's going to get harder later on. So right now, all you need to know, if I've got a coin, how many outcomes are there?
2. I can't really remember what I got.
Sample space. Those are the list of outcomes. List the outcomes.
Heads.
One coin.
Oh.
Alright, let's make it 2 coins. Okay? Sample space.
Yeah, it's 2 tails.
Head, head.
Tail,
Tail,
tail.
tail.
Then head, tail. The tail, head.
Exactly. It's all the possible outcomes. Come on, you know that's true. Don't try to take the easy way out and just say, okay, head, head, tail, tail. You know it could have been head and tail. Alright. So that's it. That's the sample space. So that's why I think you guys, you would have done bad, because maybe we would have seen sample space, you'd be like, what's that? And all it's trying to say is just list the actual.
Yeah,
Outcomes.
that's probably why we most of that.
Anyways, outcomes are 2. And then what's the probability of a head and a head? What's the probability of getting a head followed by a head? How many heads are there? How many heads are there?
Yeah, it should be 4. No.
How many head has to be?
Oh,
yeah,
one.
1. Out of how many outcomes are there altogether?
4.
So there's a quarter chance of getting head, which makes sense.
Okay.
Then the quarter chance of everything.
All right, but if I say what's the probability of at least one tail. Or I can get a tail there, I can get a tail there, and I can get a tail there.
So
Yeah,
three
that's
of
3 out of 4.
That's it. Cool. So that's probability. Hopefully that should be okay now. Geometrical shapes, we won't be able to cover that. Linear relationships, rational numbers, we've already covered that.
Linear relationships.
Surface area, volume, and linear relationships. Those are the 2 big ones, I reckon. Okay, surface area and volume. There's a lot of formulas that you need to memorize. So the sooner,
Yeah, I sort of do remember.
the sooner you sit down and memorize these formulas, the sooner this
Yeah.
topic's actually pretty easy. Surface area of a rect.
So is it like? Yeah, I thought this again. Is it like the
All you got to do,
like inside the rectangle?
it's outside.
it's all the outside, the whole
Yeah.
surfaces.
I didn't learn the surface area, so I failed.
Surface area of a rectangular prism, you got to add up all
The side. Or the
surfaces. So, if it was, for example, this thing that I've got here, that's a 6, that's a 3, and that's a 7, you go, okay, this part here, so area 1 is equal to 6 times 3.
Yeah.
Right? And then because there's going to be 2 of them, there's going to be the front here and the back here, so it's going to be times by 2.
So you do
Front
so
and back.
front and back first, and then you do
It
side.
doesn't make a difference which one you do first. No one cares.
But where did the 2 come from?
Because I'm timesing. This is the same area. The front and the back is the same area, so you can just times it by 2.
So you do that first, and then the side.
It doesn't matter which one you do first. Now, we're trying to do these sides.
Yeah, the sides.
7 times by
4. No.
Three.
3.
7 times by 3
Or
will
you
give
can
you.
do it by 6.
No, but that will give you the top and bottom.
Oh, okay.
7 times 3 and then times by 2 sides. And then area 3 is your 6 times 3 and then times by 2. That's your top and your bottom. Why am I timesing it by 2? Because it's for your top and your bottom.
Okay, so there's only two things that are big. Yeah, okay, now that makes sense. Makes sense.
It shouldn't be 6 times 3. What am I doing?
Oh,
My bad. That should be 6 times
7.
7 for top and bottom, right? 6 times 7. Thought it looked weird. 6 times 7. And that happens the same. So all I'm going to do quickly is cut area of a triangle, because you do need to know that. So area of a triangle is
Yeah, half.
half times base times height. And it's, please remember, vertical height. So if I gave you this, and I gave you that as 6, and I give you this as 10, and I told you to find the area, we can't use 6. Right? So what we got to do, we got to try to find this part here. We're going to try to find this part here.
When you do 10 times 1
So
over
that's
2,
so that's 5. That's 5 there. You got to use Pythagoras' theorem to find this vertical height. So then that is, so we'll label it as h. So h squared is equal to 6 squared take away 5 squared. 30 take away 5, 25 is 36. Sorry, that is.
So why do we need to use Pythagoras theorem?
Because you don't have, that's 11, therefore the height is square root 11. Because you don't have the vertical height, you only have the slant height. Remember, when you do half times base times height, it's vertical height, not slant. You get that? It must be the vertical height. Vertical height's this way, not this way.
So how do we know it's 7?
Will it say it or?
Say it again.
How do we know it's 7? Like,
Where's 7?
you know how you. Oh no, go on. Oh, go on. I thought that's in 7. Go on.
Where?
No, where the.
I can't see where you're pointing.
The triangle.
Oh, that's a H.
Yeah, no, right, yeah, there. If that would count.
That's a right angle.
Yeah, it looked like it's 7
Sorry.
because it.
Yeah, that's a right angle. So there it is, and then that becomes root 11. Now you can do the area, which is half times base, which is 10,
Yeah.
times height, which is
Wait,
height is root 11. That's what we just worked out.
okay. Height, 6 minus 1, 2. That equals, yeah, because you have to double it. Then that equals 11.
And you square root it.
Square root it, and then times the square root of 11. Yeah,
You get that?
got that.
Okay, let's go with a. What else? Oh, sorry, surface area shouldn't be finished. All right, surface area is finished, but all you need to know with volume is that it's an area of front shape times by depth. Okay, so if I gave you the volume of a cylinder, it's just that area times by height. If I gave you the volume of a rectangular prism, as I said before, it's just going to be your length times width, or width times length, however you see it, times breadth. So your volume is length times breadth times width. Cool? And you can keep going, like I said, any shape. Triangular prism, it's just your area of your triangle, times by depth.